Hello and good day. Welcome back to our class. This is teacher Onendi Guzman and our topic for today is proving theorems related to chords, arcs, central angles, and inscribed angles. Basically, this tutorial video is divided into 4 lessons, namely, theorems related to central angles and their corresponding arcs. Number 2, theorems related to chords and their corresponding arcs and a chord perpendicular to a diameter. Number 3, proving theorems on inscribed angle and its intercepted arc. And finally, proving theorems on angle inscribed in a semicircle and a quadrilateral inscribed in a circle. So let's have the first topic, that is theorems related to central angles and corresponding arcs. So let's review first some definition of terms. So the degree measure of the minor arc is equal to the degree measure of its central angle. So say for instance we have this illustration, okay? So we can say that, okay, the circle C, okay, the measure of angle ACB is equal to 110 degrees. And measure of arc AB is equal to 110 degrees as well. Also the arc addition postulate. So arc addition postulate states that the measure of the arc formed by the two adjacent non-overlapping arcs is the sum of the measures of the arc. So let's look on this illustration. Okay, so given that circle E, find the measure of arc ABC and measure of arc ADC. From the given, we can say that the measure of arc ABC is equal to the measure of arc AB plus the measure of arc BC. So where's that? So AB plus BC. So if we will combine together, that is 50 plus 85, so we have 135 degrees. On the other hand, if we would like to find the measure of arc ADC, so that is the measure of arc AD and add measure of arc DC. So we have 135 plus 90, so this is equal to 225 degrees. So let's consider problem number 2. So we have, if the measure of RJOS is equal to 85 degrees and measure of angle SOE is equal to 75 degrees, we want to find out the measure of RJSE. But let us recall that the measure of angle JOS is equal to its intercepted arc. So that is equal to measure of, okay, RJS. So arc JS, or the measure of RJS, is equal to 85 degrees. Similarly, so the measure of angle SOE is equal to the measure of arc SE, which is equal to 75. Since we want to find out the measure of RJSE, so we will combine this together. So we have 85 plus 75, that is equal to 160 degrees. Let's move on to another definition. Congruent circles are a circle with congruent radii. So it states that arcs in the same circle or congruent circles which have the same measures are called congruent arcs. So let us consider the two circles. So we have, okay, line segment DJ is the radius of circle D, while BF is the radius of the circle B. So if DJ, or the line segment DJ, is congruent to line segment BF, then we can say that the circle D is congruent to circle B. Let's have another theorem. So in a circle or in a congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So let us consider the following circles. So we have circle E and circle Z. So if circle E is congruent to circle Z, then angle DEA. So where's that? So angle DEA is congruent to angle BEC. So we have here DEA is congruent to angle BEC, as well as it is congruent to angle, okay, XZY. So then arc AD is congruent to arc BC, which is also congruent to arc XY. So let's move on to the theorem. Theorem, the circle or in a congruent circles, two minor arcs are congruent if and only if the corresponding central angles are congruent. So let's consider this again. So circle W and circle N. So if, okay, circle W is congruent to circle N, angle AWS is congruent to angle MNR. Follows that we want to prove the angle or arc AS is congruent to arc MR. Okay, to prove our theorem, so let's consider the illustration on the right side. So if circle W is congruent to circle N and angle AW is congruent to angle M and R, so we would like to prove that arc AS is congruent to arc MR. So again, so we will utilize for our proof for part A. We have the two column form, so we have the statements and the reasons on the right side. So our first statement is circle W is congruent to circle N, as well as angle AWS is congruent to angle M and R. So the reason is given. Number two, in the circle W, angle AWS is congruent to arc AS, as well as in circle N, measure of angle M and R is congruent to arc MR. So our reason, so the degree measure of the minor arc is equal to the degree measure of central angle. Third statement, angle AWS is congruent to angle M and R, and our reason is from one definition of congruent angles. Number four, measure of arc AS is congruent to the measure of arc MR, so that is from 2 and 3 by substitution. And finally, okay, arc AS is congruent to arc MR because from 4, we have the definition of congruent arcs. So let's move on to the second part of proof. So again, so the theorem is in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Again, so given, so if the circle W is congruent to circle N, arc AS is congruent to arc MR, and we would like to prove that angle AWS is congruent to angle MNR. Again, for our second part of our proof, so we have our statements and reason. So for number one, circle W is congruent to circle N, as well as arc AS is congruent to arc MR, and the reason is it is given. Number two, in circle W, so we have arc AS is congruent to the measure of angle AWS, as well as in the circle N, arc, MR is equal to the measure of angle M and R. So the degree measure of the minor arc is equal to the degree measure of its central angle, which intercepts the arc. Number three, the measure of arc AS is congruent to the measure of arc MR. Okay, the reason is from one definition of congruent arcs. Number four, so we have the measure of arc or angle AWS is congruent to the measure of angle M and R. And our reason is from 2 and 3, if we will combine this together, we will have actually our substitution. And finally, angle AWS is congruent to angle M and R because from 4, we have the definition of congruent angles. Let's move on to the second part of our lesson. So that is the theorems related to chords and their corresponding arcs and chords perpendicular to a diameter. So the circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So let's consider the circle N and circle A. Okay? So in circle N, CO is congruent to, okay, line segment ES. Since the chords are congruent, it follows that CO is congruent, or RCO is congruent to RES. Similarly, in circle N, okay, that is actually congruent to circle A, and CO is congruent to, okay, line segment ES, which is also congruent to line segment CR. Then arc CO is congruent to arc ES, which is also congruent to arc CR. So let's move on to another theorem. So in a circle, a diameter bisects a chord and an arc with the same endpoints if and only if they're perpendicular to the chord. So let's look on our circle N. So we have line segment AC and line segment SK. Okay, so in the circle N, SK is the diameter, okay, and AC is the chord. Yeah, okay. If SK, or line segment SK, is perpendicular to line segment AC, then AL, okay, line segment AL is congruent to line segment CL, as well as the arc AS is congruent to arc CS. Okay, in a circle or incongruent circle, two minor arcs are congruent if and only if the corresponding chords are congruent. So let's consider the following two circles, circle R and circle M. So given the circle R is congruent to circle M and AE is congruent to OP. So we would like to prove that arc AE is congruent to arc OP. So before we can proceed to the proving of this particular theorem, so let us draw first the line segment AR, okay, as well as the line segment RE, as well as the line segment PM and line segment MO or ON. So again, so given the circle R is congruent to circle M, AE is congruent to OP, so we would like to prove that arc AE is congruent to arc OP. So again, for the first part of our proof, so we have, okay, statement number one. So circle R is congruent to circle M. So AE is congruent to OP. So the reason is it is given. While for statement number two, so we have RE is congruent to RA, is also congruent to MO, which is also congruent to line segment MP. So the reason is the radii of the same circle or of congruent circles are congruent. Number three. So therefore, we can create actually a triangle. So we have triangle ARE. So we have the triangle ARE is congruent to the triangle OMP. The reason is that is the SSS postulate, or side, side, side postulate. Number four. So we can say that angle ARE is congruent to angle OMP. The reason is we have the corresponding parts of the congruent triangles are congruent, or CP, CT. Okay, and finally we have, okay, arc AE is congruent to arc OP because in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Let's move on to the second part of the proof. So this time, okay, the given circle R is congruent to circle M and arc AE is congruent to arc OP, we would like to prove AE is congruent to OP. So for the second part of the proof, we have again the statements and the reason. So statement number one, so we have circle R is congruent to circle M, and arc AE is congruent to arc OP. So the reason is it is given. Number two, okay, the measure of arc AE is congruent to, okay, the measure of arc OP. And the reason, this is the definition of congruent arcs. For number three, so we can say that angle ARE is congruent to angle OMP, or that are actually central angles. And the reason, we have the definition of central angles. Number four, so we can say that angle ARE is congruent to angle OMP. For our reason, so the degree measure of the minor arc is the measure of the central angle which intercepts the arc. And finally, we have measure of, okay, angle ARE is congruent to the measure of angle MOP. And the reason is from 2 to 4, we can have our substitution. To continue with our proof, so observe that I draw a line segment, okay, from, okay, point or center R. So we have here line segment AR and line segment RE, as well as line segment MP and line segment MO from the center or from the point N. So if we will continue our proof in number 6, so our statement will be RE is congruent to RA, which is also congruent to MO, which is also congruent to line segment NP. And the reason is radii of the same circle or of congruent circles are congruent. Number 7, so we have triangle ARE is congruent to triangle OMP. So we can have actually the side angle side postulate. Okay, and finally for number 8 we have, okay, line segment AE is congruent to line segment OP. So finally, we've been able to prove this. So our reason is corresponding parts of the congruent triangles are congruent. Let's move on to the third part of our lesson. So that is proving theorems on inscribed angle and this intercepted arc. So the theorem states that if an angle is inscribed in a circle, then the measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So let us consider the circle E. So we have here, okay, angle CAR is in the figure an inscribed angle with CR or arc CR as its intercepted arc. So we can say that the measure of CAR or arc or angle CAR is equal to 95 degrees. Then the measure of, okay, arc CR is equal to twice 95 degrees. So that is equal to 2 times 95 is equal to 190 degrees. So let's have another example. So we would like to solve for x if angle CAR is equal to 35 degrees and arc CR is equal to 4x minus 2 degrees. So again, so we will start with the measure of angle CAR is equal to 1/2 the measure of arc CR. So again, by substitution, so we have 35 is equal to 1/2 times 4x minus 2. Again, I would like to remove the 2 as the denominators. I multiply both sides of the equation by 2. So I have 35 times 2 is equal to 4x minus 2. So 35 times 2 is equal to 70 is equal to 4x minus 2. Then add both sides by 2. So I have 70 plus 2 is equal to 4x. So we have 72 is equal to 4x. Solving for x, so divide both sides by 4. So x will give us the value of 18. This time, let's move on to proving of theorems. So case number 1 is the center of the circle lies on one side of the inscribed circle, such that we have if an angle is inscribed in a circle, then the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. So that is why on our, okay, proofs, so given that the circle O with inscribed angle, okay, angle BAC, so we have angle BAC and, okay, line segment AC is the diameter. So we would like to prove that the measure of angle BAC is equal to 1/2, okay, measure of arc BC. So for our proof, so our statement number 1, circle O with inscribed angle and AC or line segment AC is the diameter. Okay, so we have the reason is this is given. Next, number 2, we would like to draw line segment OB. So the reason is 2 points determine exactly one line. And number 3, we can say that OA or line segment OA is congruent to line segment OB. And the reason is the radii of a circle are congruent. Number 4. So we can have actually the triangle BAO is an isosceles triangle because we have the definition of isosceles triangle. And number 5, angle BAC is congruent to angle OBA. Moving on, because for our reason, we will move on to the reason of isosceles triangle theorem. Moving on for our number 6 statement. So we have angle BOC is equal to the measure of angle BAC plus the measure of angle OBA. So let's look on that one, guys. So we have angle BAC plus OBA. The reason is measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Statement number 7. So we can have the measure of angle BOC is equal to, measure of angle BAC plus measure of angle BAC because we've been able to substitute the value of measure of angle OBA is the same as measure of angle, BAC. So take note that I can combine together. So this is actually 2m or twice the measure of angle BAC. The reason, so we have the substitution property. Number 8. So measure of angle BOC is equal to arc BC because the measure of the central angle is equal to the measure of its intercepted arc. Number 9. So we have two measure of BAC is equal to measure of arc BC. The reason is the transitive property of equality. So we have here two measure of BAC. We change that one to the value of measure of BOC. So that's why we come up with the measure of arc BC. So finally, so if we will divide both sides of the equation by 2, so we have the measure of angle BAC is equal to 1/2 measure of arc BC. And for our reason, that is the multiplication property of equality. So let's move on to case number 2. So that is the center of the circle lies in the interior of the inscribed angle. So again, so the given is circle O with inscribed angle BAC. So we would like to prove that the measure of angle BAC is equal to 1/2 the measure of arc BC. Okay, so this is the arc BC. So again, to prove this one, we need to draw a diameter AD that will pass through the circle O. Okay, so to show our proof, so we have statement number 1. So the measure of angle BAD is equal to 1/2 measure of arc BD. So again, so this is our case number 1. And number 2, that is the measure of arc CAD is equal to 1/2, measure of, arc CD. So again, we can state our case number 1. Okay, for number 3, we can actually add measure of BAD plus the measure of CAD. This is the same as 1/2 the measure of arc BD plus 1/2 the measure of arc CD. Our reason is simply as addition. Number 4, we have the measure of arc BAC is equal to 1/2 measure of arc BD plus the measure of arc CD. Take note that I factored out 1/2. Reason here on this side, right hand side, as factoring or distributive property, or simply as we have the addition property of equality. Okay, so we have here also for number 4. And for number 5, we can have the measure of arc BAC is equal to 1/2 the measure of arc BC. So I use the arc addition postulate. Let's move on to the third case. So that is the center of the circle lies in the interior of the inscribed angle. Okay, again, so the given is circle O with inscribed angle BAC. And we would like to prove that the measure of angle BAC is equal to the measure of arc BC. So to prove that, we need to draw diameter 80. So we have here diameter 80. Okay, so for our statement number one, so the measure of, okay, angle DAC is equal to the measure of angle RDC, and measure of angle DAB is equal to 1 half, okay, measure of arc DB. So we can state our reason as case number one, or we can say that the measure of the inscribed angle is equal to 1 half the measure of its intercepted arc. Number two, so we have the measure of angle DAC plus the measure of angle BAC is equal to DAB. Or measure of angle BAC is equal to measure of angle DAB minus measure of angle DAC. Our reason is angle addition postulate. For number 3, so we can have arc DC plus arc BC is equal to arc DB, or measure of arc BC is equal to measure of arc DB minus, okay, the measure of arc DC. So I can say here this is as arc addition postulate. For number 4, we can have measure of angle DAB minus the measure of angle DAC is equal to 1 half measure of arc DB minus 1 half, okay, the measure of arc DC, or we can have also the measure of angle DAB minus the measure of angle DAC. So we can factor out 1 half. So we have 1 half times the measure of arc DB minus the measure of arc DC. So we have here simply a subtraction. And this time on the right hand side, I can use the factoring method or the distributive property. And for finally, we have the measure of, okay, angle BAC is equal to 1 half measure of, okay, BC simply as the substitution. So let's move on to the last part of our lesson. So that is proving theorems on angle inscribed in a semicircle and quadrilateral inscribed in a circle. Okay, so if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. So let's consider the figure on the right side. Okay, so given the circle O, so angle ABC intercepts the semicircle arc ASC. So we would like to prove the angle ABC is a right angle. Okay, for our statement number one, that is the, okay, arc ABC intercepts the semicircle, okay, arc ASC, and the reason is given. For number 2, the measure of angle ASC is equal to 180 degrees because the degree measure of the semicircle is 180 degrees. For our third statement, the measure of angle ABC is equal to 1 half measure of arc ASC, and the reason is the measure of an inscribed angle is 1 half the measure of its intercepted arc. For statement number 4, we have the measure of angle ABC is equal to 1 half times 180 because we substitute the value of, okay, measure of angle ASC. So we can say that the measure of angle ABC is equal to 90 degrees. Obviously, the reason here is substitution. For number 5, we can say that the measure of or angle ABC is a right angle because we have the definition of right angle. For the next theorem that we will prove, that is, if a quadrilateral is inscribed in a semicircle, then its opposite angles are supplementary. So let us consider the figure on the right side. So we have, okay, given quadrilateral OBAL inscribed in circle Y. Okay, so we would like to prove that angle O and angle A are supplementary, as well as angle B and angle L are also supplementary. So to prove this, we draw, okay, OY, line segment OY, BY, AY, and line segment LY. So for our statement number 1, we have the measure of angle, okay, angle OBY equals thus OBY plus the measure of angle BYA, so we have BYA plus the measure of angle AYL plus the measure of angle LYO is equal to 360 degrees. So the reason is the sum of the measures of the central angles of a circle is 360 degrees. For statement number 2, measure of angle OBY is equal to arc OB, as well as the measure of angle BYA is equal to arc BA. Here's the BA. Okay. Then we can say that, okay, measure of angle AYL is equal to arc AL, and measure of angle LYO is equal to measure of arc LO. So because the measure of the central angle is equal to the measure of its intercepted arc. Moving on, so we have measure of arc OB plus the measure of arc BA plus measure of arc AL plus measure of, okay, arc LO is equal to 360 degrees. So we can have the substitution. So we substitute the value of this 360 with this statements 1, 2, and 3. Okay, moving on for number 4, we have the measure of, okay, arc LAB plus the measure of, okay, arc LOB is equal to 360. So that is arc addition postulate. Okay, for our statement number 5, so measure of, okay, angle LOB is equal to 1/2 the measure of, okay, arc LAB, and the measure of angle LAB is equal to 1/2 the measure of arc LOB. So that is the measure of an inscribed angle is 1/2 the measure of its intercepted arc. For number 6, we have the angle LOB plus the measure of angle LAB is equal to 1/2 the measure of arc LAB plus 1/2 the measure of, okay, arc LOB, or we can say that the measure of angle LOB plus the measure of angle LAB is equal to 1/2 the measure of, okay, arc LAB plus arc LOB. So take note that I factored out 1/2. So we can say this is actually what we call by addition, or simply on the right side, I use the distributive property of equality. Number 7, so we have, okay, measure of angle LOB plus the measure of arc LAB is equal to 160 degrees, or the measure of angle LOB plus the measure of arc LAB is equal to 180 degrees. So I use here the substitution also. For number 8, angle O and angle A are supplementary because the definition of supplementary angles. Let's move on to statement number 9. So we have the measure of angle O plus measure of angle B plus measure of angle A plus measure of angle L is equal to 360 because the sum of the measures of the angles of a quadrilateral is 360 degrees. For 10th statement, so we have the measure of angle B plus the measure of angle L plus 180 is equal to 360 because we use the substitution, okay, from the earlier statement. So number 11, so we have angle B, or measure of angle B plus the measure of angle L is equal to 180 degrees. So this is, we use the addition property of equality. And for our final statement, so angle B and angle L are supplementary, okay, because we use the definition of supplementary angles. So this is, okay, the end of our lesson. So hopefully that you've been able to learn something from this, okay, proving of statements. Again, so this is Teacher Oneni Guzman. Thank you, and do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.